So this will be our last video on multiplying matrices and adding and subtracting them. And so the leading question is, we know that 2 times 3 is equal to 6 and 3 times 2 is equal to 6. But if A and B are matrices, does A times B equal B times A? In slightly different language, more technically minded, does matrix multiplication commute? Does the order change the outcome? And so there's a couple different cases. One where the matrices are different sizes, and one where they're the same size. So we're first going to look at the case where they're different sizes. And different sizes works out really nicely because multiplication of matrices has a size requirement. And if you don't meet the size requirement, you don't actually have to do the multiplication. So we have A times B is our first scenario. A, we can see, is a 3-row by 2-column matrix. So 3 times 2. And B, we can see, is 2 rows by 2 columns. So 2 times 2. If I then pick a different color, I can see that our first size is going to be matching the inside numbers. So A times B would be a 3 times 2 matrix. Now let's consider what would happen if we have B times A. B is still a 2 by 2 matrix. A is still a 3 by 2 matrix. But because we've changed the order, our middle numbers do not match. And so even though A times B is defined, B times A is undefined. So we can say that when they are different sizes, A times B is not equal to B times A. And this is always true. Next, we have the case where they're the same size. So 2 by 2 and 2 by 2. And we know we can multiply it in both orders. No matter which one comes first, A or B, the middle numbers are going to match. So it's defined. Both of these exist. The question is, are they the same? And so we get to have some extra practice multiplying matrices to find out. So our first matrix is 2, 5, 0, 0. And our second matrix is 3, 1, 8, 1. Our new matrix is going to be 2 times 3 plus 5 times 8. So that's 6 plus 40, 46. And then 2 times 3 plus 5 times, hold on, I'm making a mistake. I'm not being very attentive to what I'm doing because I'm now on the second column. So it's 2 times 1 plus 5 times 1. So 2 plus 5 essentially, and that is 7. Finding the numbers for our second row is going to be really easy. because 0 times 3 plus 0 times 8 is 0, and 0 times 1 plus 0 times 1 is also 0. So our second example flips the order. So we have 3, 1, 8, 1. And then we have 2, 5, 2, 5, 0, 0. And I'll change back to my other color. Here we have 3 times 2, which is 6. And then I really should have written this more clearly. This is a 0, not a 6. So whatever number is in our second spot is going to be times 0. So we have 3 times 2 plus 0, so this is 6. 3 times 5, 15. Again, because that second number is 0. 8 times 2 plus 1 times 0 is 16. And then 8 times 5 plus 1 times 0 is 40. So we can conclude that even when they are the same size, A times B does not equal B times A. But I have a question for you. Are these always true? We can give examples where A times B does not equal B times A, both when we have different sizes and the same size. Are there matrices that we can come up with? And can you think of them that A times B is defined and B times A is defined and they're equal? Or is this always true? The question of always in math is a very important question. And for many topics, it has stumped many mathematicians. But it's a really good exercise in deeply understanding the concepts, not just the procedures of math. So this is going to wrap up where we finish. Maybe I'll give an extra video and I'll tell you if they're always not true or if we can do some math to make it work. But mainly, here are some practice questions. So we want to use matrix algebra to answer each question. So A and B are related. Then C is separate, and D has some additional parts related to two different matrices. So that is it for this lesson. Thanks for watching.